Ma'am, you are not audible. Hello.
Yes, ma'am.
Okay. So the thing is that the objective, after learning the objective, the course outcome will come after the completion of your the 3 to 4 months completion of the course. Once you complete the course, then only it is possible to understand, to formulate, to write the equation, to analyze the things, to, and you can say the major thing is nothing but the designing part. Before that, it's not at all possible to understand each and everything, how you are getting the things at a particular application. You should be able to find out the frequency required for that, the wavelength required for that, the bandwidth required for that. You must be able to understand whether it's a wired or the wireless antennas, whatever the things means. You should be able to perfectly understand what is the formula, what is the derivation, what is the wave equation, all these things. The analysis, the understanding, and the designing part is expected after the completion of this course only. Okay, so this was the related to the course outcome. So that's why one of the example I will give. Just now, we many faculty members, they have taken the course exit survey. So that is nothing but we are expecting after the completion what you have understood. Before, what was your knowledge, and after completion, what was your knowledge, what you have understood each and everything. Okay, so in this way, this comes under the course outcome. Now come here, go through the syllabus of your the AWP, that is nothing but antenna and wave propagation. So in this antenna and wave propagation, the unit number 1 is nothing but your uniform plane wave. I hope this you will feel this subject is easy as compared to the electromagnetic field theory, because many things to the laser form waveform, and we are interested write ourselves the wave equation. Getting similar to that only, the uniform plane wave, where the uniformity throughout the from the at the beginning to the terminating point. If we are getting the wave, when the wave will be propagating, the uniform plane wave is nothing but uniform plane wave. In the homogeneous form, that is nothing but again we are interested to find out the two phases, that is nothing but in the free space. Okay, or a boundary condition, that we need to take care in the homogeneous part. Similarly, the free space, the dielectric, and the conducting medium. It means that by considering, by assuming that is the wave is propagating in the free space, what will happen when the wave is will be propagated, or considering the dielectric, when the wave will be propagated, well, by considering the conducting medium. So if medium is changing, what will be the effect? Okay, while you are going to write the equation or the wave functions. Okay, so that will we will go through one by one once we will start the session. Okay, now the next point is nothing but the polarization. So already we have studied how the polarized, okay, how the, just take the example of your the cells, and we know very well the cell will be act. Okay, and even the human body is just like your the power station. Many cells we are having in our body, and that will be what you can say polarized excitation. If once is given, the you know very well the mind will be excited and the activate and the work it. So similar to that, the polarization and depolarization will be at. Similar to here, whenever we are changing the things in terms of the voltage and the current and the mode, if we are changing that time in the waveform, so that time these things are too important. How the polarization, that is the linear, if my what we can say medium, or you can say in the linear form, so how my wave will be propagated linearly, how my the waveform will be excited, okay, how long they are working, all these things we need to take care, similar to circular, elliptical form. Okay, so that will become in the polarization. Next is nothing but the reflection of the plane wave. Okay, that already we are aware from this word refraction, reflection, in incidence, and the angle, critical angle, all these things, how we are going to calculate how my wave will be what we can say perpendicular, that time what will be happen if incidence refraction is going on. So these things, basic things, the normal incidence and oblique incidence, all these things we will go through, we will study deeply in this chapter. Okay, the last is the content in this chapter is nothing but the electromagnetic power and the Poynting theorem and the vectors. Already this point we have covered in the electromagnetic field theory, that is nothing but the power. So if you are talking about the power, definitely you should think about the voltage and the current equation, wave equations, along with your the Poynting theorem and the vector. If you're talking about the Poynting theorem, the scientist names which is derived in terms of the vector also, P is equals to V into I, but that is in the electric and the magnetic field, the formula will be different. Along with that, how you are getting the average power by the voltage and the current equation you are going to write for the EM wave. Okay, so that time this particular theorem is useful for finding out the average powers. Okay, how we can write the vector equation. So all these things we will study in the chapter number 1. Similar to that, in the chapter number 2, which is nothing but your the wave propagation. In the wave propagation, so fundamental equations for the free space propagations we are interested. There is a transmission equation, that is one of the scientists name. So thereby we are going to write the transmission equation. Already we are aware from the transmission line and the equivalent circuitry. In that the 4 components, that is nothing but your the resistor, inductor, capacitor, and the conductors. They are connected in the series as well as the parallel in the transmission line. So even the primary constant and the secondary constant, you are aware from these things. Okay, so by considering that transmission line, we should able to write the equation. Okay, while we are at the source side, what will be the effect? If you are at the terminating side, what will be the effect? And how you can write the transmission equation by considering the length also, that is nothing but the lambda wavelength. Similar to that, in this chapter we will study about the attenuation over the reflecting surface. Okay, so what is mean by the attenuation, how you can measure in the Nipper and the decibel, all these things, and you are interested to find out as per your the reflecting surfaces. Similar, the effect of Earth's curvature and the ground, sky, and the space wave propagation. We are already aware the Earth is a curvature form. So at the time, if what we can say the transmission line, I will show you with the help of the figures. I will show you if the tower is there at the source and the destination side, and the what we can say the wired the transmission line is there. So how the things will come, that is the skin depth and the other what we can say the losses will be occur while the connecting from the source to the destination, if you are having the tower. Okay, if you are having the tower and the lines are going from the source to the terminating point, the just because of that curvature, what will be the effect, how you can measure from the ground, from the sky, and then the free space, how your particular wave will be propagated. So that effects we need to check. Okay, similarly, the structure of the atmosphere, the characteristics, the ionization effects, the what we can say the virtual heights, what is mean by the MUF, skip distances, all these things, the characteristics of wireless channels, fadings, multipath, all these things will be affect for the antenna, because the antenna is receiving, antenna is transmitting. So definitely these characteristics and the parameter will be affect. Similar to that, the third chapter is on the basis of your the antenna fundamentals. We will go through the introductory part, the types of antennas, the radiation mechanism, the radiating power, antenna efficiency, polarization effect, and all. So similarly, the next chapter is nothing but the chapter number 4. That is nothing but the wire antennas. The one of the type of wire antennas we are interested, which is most widely used for the analysis of that. What is mean by the loop? How we can find the finite length? What is mean by the dipole, half dipole, full dipole? All these things we will study. We will analyze all these things in the chapter number 4. Similarly, the antenna arrays. What is the effect of arrays? Why we can? Why we must go through the arrays? What is the effect? What is the benefit of that arrays? Because the antenna and antenna arrays, simple antenna and the antenna arrays, what is the difference of that? Which parameter we need to calculate? What is the n element array, binomials, all these things. And one of the two important antenna comes under the array is nothing but the Yagi Uda antenna, that already you have seen and you have what you can say hear from your parents, okay, about the Yagi Uda antenna. The last chapter will, which is totally related on the designing part or application part, you can say how the dimension should be there, how the radiation pattern should be there, what should be the application. Accordingly, you can design, you can place, you can use the particular antenna while you are making the any kind of project, mini project, major project, or you are working in a company for this in the particular domain. So that time designing part is too important. We remember designing part is too important. Minor things you should be able to understand. What should be the length, wavelength, simple length, frequency, bandwidth, each and everything. That designing part will become under the antenna for depending upon the application. Okay, so now come to our introductory part of your the antenna. So what is mean by that antenna? We will see here the history behind this antenna is nothing but the first antenna were built in the 1988 by the German physician. You can say that the name, full name is nothing but you are the Heinrich, okay, hertz. That's why many times we use the unit of hertz, okay. So that introduced, or you can say invented this the antenna, okay, along with your the predicted by the theoretical part will be predicted by the James Clerk at the Maxwell's. Similarly, the work was going on how the many things were calculated, find out with the help of that scientist what is the dipole antennas, how the focal point we can find, what is the parabolic reflectors, how the transmitting and other things we can find in the 1988. Okay, so now come here, what is mean by the antenna? Already we are aware antenna is an electrical device which converts the electrical current into the radio waves and the vice versa. In short, what we are converting, electrical signals are converted into the radio, or the radios are connected into the electrical signals. Okay, so in short, you can say the radio transmitter and the usually the receivers is used. So in the transmission of your the radio transmitter as well as the receiving, the oscillating radio frequency will be required. Okay, on the terminating point, and how they can radiate, that is important. And all these things are going on, no doubt at all, in the EM wave, that is nothing but in the form of the radio waves. Okay. So here the two things are too important. That is nothing but you are the transmitting antenna as well as the receiving antenna. So transmitting antenna at the source side, the receiving antenna is at the terminating point or the receiving points. So two antennas are placed at a far distances, and you need to find, and the EM wave will be propagated from in between the transmitting antenna to the receiving antenna with the help of the so and so wavelength. Okay, and that depending upon the application, the frequency will be different, and from the source side we need to amplify the signals while you are going to transmit. Okay, so all this thing you need to take care, and even at the receiving point, how you can increase the efficiency, that matters, how the structure is there, how the design part is there, and as per that only you can remove the unwanted signals, and you need to receive the signals with the help of that receiving antenna. What is the need, or you can say the purpose of using the antenna is nothing but the when the two persons wanted to communicate between them, when the separated by some distance, or the wider communication is not at all possible, because if the distance is far, it's not at all possible to hear the things whatever the communication is going on. So antennas are required by any radio receivers or the transmitter to couple it in the electrical connection to the electromagnetic field, so that the communication is possible. You can hear each and everything. Okay, you can transmit, you can receive the things. Okay, so radio waves are electromagnetic waves which carries the signals through the airs in the space, you can say, and as per that the speed of the light, you can find out the parameters. So simply here the two things are important. That is nothing but if antenna is placed at the one side, we can say at the one side. So what you are going to observe, the receiving and the transmitting signals are important. And in the space, no doubt at all, the EM waves will be there, or you can say the radio waves will be there, and the band will be in the conductive waves. Okay, so in this way, the magnetic field strength, the electric field strength, and the parameter you are aware, that is nothing but the E, H, and the BD. All already we have studied in the EFT. That is a four parameter basically. Four parameters: E, H, BD, and mu R, mu zero, likewise epsilon zero, epsilon R, and epsilon zero likewise. So these are the basic parameters we need to calculate while the wave will be travel from one place to another place, radiating. Okay, these things are too important. So in this way, the radio transmitter and receivers are used to convert the signals, the information. Signals is in the form of the information in the broadcasting, the radio, television. These are the applications of you while you are going to transmit the signals. How you can transmit for the purpose of you are including your broadcasting for the audio purpose. Okay, radio purpose, the television, mobile telephones, the point-to-point communications. Okay, all these things is possible. So radio waves are also used directly for the measurement of technology, just like you are the radars, you are the GPS, you are the radio astronomers. Okay, so even one of the example is at the airport also. If you have visited on the top of the sixth floor, we have visited on that top, one of the radar is also that the signals you can observe easily how the planes, the communication between the in the space and the from the airport, that is also possible to calculate all these things. So in each and every cases, the transmitting and receivers involves requires the antennas. Okay, so these are the basic application for understanding how why the need of the antenna is there for the communication link and the purposes. Okay, so even in the AM radios inside the laptop computer is equipped with the Wi-Fi. That is also one of the example you are aware from this, how we are getting the wireless your if you are going to connect the Wi-Fi and all the data usage, how you are going to use the what we can say the internet and all these things. So the thing is going on with the help of the radiation mechanism. And this radiation mechanism, if here the generator or the source is there and the sinusoidal waveform is there, how the waves are can be what we can say radiates. This is the example of radiations, okay, patterns. So ideally incident energy must be reflected back when open circuit. Okay, and practically small portion of the electromagnetic energy from the system, it is get radiated. Okay, so this is happen if the sinusoidal waveform is there and the source is connected, the wave will be radiated. See here the pattern of your the antenna, wherever even though your source is connected here, one is fully connected, there is no open source, but at the terminating side you will be able to find at the far end, you will be able to find this is the open circuit. Right, to increase the amount of the radiated power, open circuit must be enlarged. See here the size and the shape of the this here the in the antennas you will be able to find in many places. Horn antenna is one of the best example of the shape. See here, just to increase the amount of radiated power at the particular open circuit to enlarge, so that portion will be enlarged. Okay, by spreading the two wires. Due to this arrangement, the coupling between the transmitting line and the free space will be improved. This is the reason behind that. Because of that only, this is the large one. Okay, radiated efficiency will be increases. Okay, amount of the cancellation of the signals will be reduces, and the what we can say the conductor of the transmission lines are to be bent so as to bring them in the same line. So that is possible. Okay, so in the types of antennas, so various types of antennas are there. Various types of antennas are there. That depending upon again you can say the shapes, the size, the application, they are classified. So one of these two are the basic antennas, that is the omnidirectional and the directional. You can say this is depending upon the direction we can say these are the types and the classifications. So omnidirectional, okay, so that is only the weak direction or weakly directional antennas which receives or radiates more or less in all directions. So these are the employed when the relative